Hello, this is Mrs. Huntley. We are in Module 4, Systems of Equation. This is a video on solving systems of equations with substitution, Part 2. Please open your packet to page 24, and your page should look something like this, where it says Systems of Equations Student Handout number 5 in the corner. I would like you to add the essential question at the top. When I'm solving a system of equations using substitution, what does a no solution or an infinitely many solutions answer look like? Now, we've been doing this in class for several days now, so today's video is much more like a review than it is new teaching. So hopefully you're going to be watching this and you're going to be thinking, yep, I got this already. So a system of linear equations that might have, there's three possibilities when you're solving a system of linear equations. Could have one solution, no solution, or infinitely many solutions. We've already been through this with graphing, and it's the same thing when we're using substitution, except we're solving the system algebraically instead of on a graph. And actually, we could do it both ways. So remember back to December when we were just solving equations, when we only had one equation in one variable, but then we had variables on both sides of the equation and we had parentheses and it got very complicated. So when we were solving those equations, we had, again, three possibilities. There was either one solution, one number that would make the equation true. There was any number that would make the equation true, that would be an infinitely many, or there was no number that would make the equation true. It's kind of exactly the same thing here. So these next couple of lines, your friend is solving an equation and her last line of her work says 2 equals 2. What does this mean? Well, remember back to December when we have a true statement, when our variable terms drop out and we have a true statement left, it means the equation has infinitely many solutions. The next possibility, as your friend is solving a different equation and the last line of the work says 2 equals 1, what does this mean? Well, 2 doesn't equal 1. It's not true. And when your variable terms drop out and you're left with an untrue statement, it means the equation has no solution. So let's take a look at what a system will look like if it has no solution or infinitely many solutions. So let's look at number 1. Our first equation says y equals x plus 4. I'm going to put parentheses around that because I want to hold all those pieces together, and I'm going to pick them up and I'm going to substitute them into the second equation in the place of the y. So I'll have negative 4x plus 4. Instead of writing y, I'm going to say x plus 4 because I'm substituting in what y equals in place of the y, and the rest of the equation equals 3. So now I have parentheses, so I've got to distribute to remove them. So I'll have negative 4x plus 4x plus 16 equals 3. Negative 4x plus 4x, I'm going to combine some like terms here, and that's 0. So I'm left with 16 equals 3. Well, 16 does not equal 3. It's not a true statement, so there's no solution to this system. It doesn't mean the system's wrong. There's just no number that will make both equations true at the same time. So if we were graphing this system, it's going to look like parallel lines. Remember when we were solving with graphing, we said the place where they crossed is the solution. So if the lines never cross, there is no solution. Let's take a look at our next example, number 2. We have y equals 3x minus 2. We're going to put parentheses around that because, again, I want to pick up that entire quantity, 3x minus 2, and substitute it in place of the y. So I'll have negative 6x plus 2. Instead of y, I'm going to write 3x minus 2 equals negative 4. I'm going to distribute to remove those parentheses. So I'll have negative 6x plus 6x, 2 times negative 2 is going to be a negative 4 equals negative 4. So I've got negative 6x plus 6x. I'm going to combine those like terms, and I'll have negative 4 equals negative 4. And that is true. Negative 4 does equal negative 4. So any number, any ordered pair that is going to make one equation true will also make the other equation true. And we say that there are infinitely many solutions. So what would a graph of this system look like? One line would be graphed on top of the other line, or it would look like one line. It would look like the same line. Okay? Both equations would look like the same line. What I'd like you to do right now is pause the video and see if you can solve number 3 on your own. Okay? Put your parentheses around, substitute in, rewrite the equation. Oh boy. Hopefully you paused and now you're looking at this going, well, what are you doing, Mrs. Huntley? Because obviously I made a mistake there. Okay, so instead of y, I'm going to say 1/4 x minus 1 equals -4. Got to distribute. Negative x. 4 times 1/4 is 1, or just plain old x, because I don't have to write the 1 in front of it. Positive 4 times -1 is going to be a -4. Combine like terms. So again, this one's going to be infinitely many. It doesn't mean any number will make the equation true. It means any number, any ordered pair that makes the first equation true will also make the second equation true. So again, what would this look like? It would look like the same line. I'm going to invite you again to pause the video and see if you can solve the next one on your own. So again, watching me do it, copying down what I'm doing, everything's easy. You're like, I've got this, no problem. It's when you try to work through it on your own that you find the difficulties. So this one I've got -2x plus, instead of y, I'm going to say 2x minus 1 equals 2. There is nothing to distribute. A +1, if I distribute the +1 to everything inside the parentheses, it just comes out the same way. So I've got -2x plus 2x minus 1 equals 2. Combine your like terms, and you have -1 equals 2. That's not true, so there's no solution. What is this going to look like? Hopefully you've got that already. It's going to be parallel lines. Again, it doesn't mean that the system is wrong. It just means that there is no ordered pair that will make both equations true at the same time. Okay? So if I am summarizing this lesson, when you are solving a system of equation using substitution, we go through the same order of what we've been doing all along. You put the parentheses around whatever that y equals or the x equals, and you substitute that in place of the variable in the second equation. If your variable terms drop out and you're left with something that is untrue, there is no solution to the system. If you were graphing the system, it would look like parallel lines. If the variable terms drop out and you're left with a statement that is true, that means infinitely many solutions. Whatever ordered pair makes one equation true will also make the other equation true. If I graph the system, it's going to look like I just have one line, or one line is going to be graphed right on top of the other line. So I told you it was going to be a short video today, and what I'd like you to do is, if you've got more time left to be working on math, make sure that all of your work through page 24 is now complete, and we will be checking for HARP tomorrow. So have a good night, and I'll see you tomorrow.